Last time we looked at energy stores. Now, there are two different things that are very, very similar in wording, and you've got to know the difference. All right. So, can you all make sure that you are on Google Meet so you can see me? All right. So, you have energy stores, and I'm briefly going to go through it, mostly because Jack's new, and maybe another couple of students are new. So, I'm going to go through it. Okay. Now, if you can't remember these, don't worry. All right. And I'm going to go pretty quickly, but as this is recorded, you can always listen through it. There are a number of different energy stores, and the way that I remember them is by, and what people think is just because I used to be a scientist, I've got a really good memory. I haven't. My memory is the same as everybody else's. So I remember it by this little interesting sentence. Most kids hate learning GCSE energy names. Most magnetic, kids kinetic, hate heat, learning light, G gravitational, C chemical, S sound, E electrical, energy elastic, they can be either way around, and names nuclear. I've gone through that really quickly because the honest truth is sometimes I'll miss one out, and sometimes I'll just completely forget one, But as I said to you last time, when we're talking about energy stores, when we're talking about energy, it has to be one of these. And it comes to be a real problem when we look at things like cars. Okay. If I said to you, what kind of energy do you put into a car? 90% of people turn around, or probably 99% of people turn around and say petrol, diesel, gasoline, something like that. That isn't one of the key words. I didn't ask what fuel do you put in. My question is very specific. What energy source do you put in? And it is chemical. So, food, batteries, and fuel are all chemical energies. And that's quite annoying when you're young. And one thing I said to you at the start of this year, science is a language, and you have to understand and learn the words that we use. And there may be the same words in English, but we're not speaking English, we're speaking science. When you hold a ball off the ground, this is gravitational, this is nuclear, this is elastic, this is heat, this is electrostatic, and this is magnetic. Now, don't worry too much about these. I've gone through them quite quickly. We did do them a couple of weeks ago, and you're more than welcome to go over this lesson. Okie dokie. So those are energy stores, and what we're going to look at today, let me just change colour. We are going to look at, I'm going to make it slightly different. Ooh, nice purple. Energy transfer pathways. And what that means is, how do you change? So how do you change? Let's just pop a sticky note over here. How do you change from one form to another? All right. You cannot create or destroy energy. That is a fundamental principle of physics. You just can't do it. All you can do is change it from one form to another. That's it. And how you do it is through an energy transfer pathway. And these are the things that we're going to learn today. So, energy stores. We just looked at chemical, kinetic, gravitational, rah, rah, rah. This is where energy is. Now, be careful. It's not where energy is made. It is where energy is. Okay? Energy transfer pathway. How energy moves from one store to another. Right now, I'm talking, you can hear my voice. I had breakfast this morning. That is a source of chemical energy. And I am transferring it and changing it into sound energy. Okay, there are four that you need to know. Technically three, and you'll see what I mean by that. All right? Mechanically, this is your first energy transfer pathway. Right? It's when you move something. It's when you push something or you pull something, or in this case, when you hit a hammer with a nail. Right? It is mechanically transferring energy, a push or a pull. All right? The second is electrically. That just means when I've got a battery or a power source and I turn on a light, you are electrically transferring that energy from chemical to light. Okay? By heating. Now, this is the thing. There are actually, in terms of heating, three different ways. Oopsie daisy, that's too big. My bracket's too big. All right. There are three different ways of heating things. All right. And I'll give you examples from here. These two can only happen if you have atoms around. And we looked at atoms last week. Everything is made up of atoms. Remember my joke? Well, I'm not sure if I told you that joke. Oh, yeah, I think I did. Why can you not trust atoms to make up everything? That's the atmosphere, you, the table you're sat on. Everything is made of about atoms. If you have atoms, you can transfer heat by conduction or convection. Conduction is through solids. I love cooking, and my wife thinks I'm absolutely silly. I'll say, "Oh, is that hot? Is that pan hot?" And I'll touch it, all right, to see if it's hot. And they'll go, "Ow," and she'll just give me a look going, "Oh." So, conduction is transfer of heat through solids. In a few months, we're going to look at it in more detail. When you have liquids or gases, that is called convection. A classic one is hot air rising. That's why hot air balloons rise. But it's also why we have weather systems. That's why we get wind from. But that's a different story. All right, radiation. And this is really, really, really important. Radiation is made of the same thing as light. And you'll hear this term. As you know, as I said, I'm going to use some really complex language. Electromagnetic radiation. This is light. But one part of it is radiation. Electromagnetic radiation. One part of it is light. One part of the electromagnetic radiation spectrum is light. Some is X-rays. Infrared is really important. That is heat. You will look at that in way more detail later on. But I want you to get used to these complex words that I'm using. All it means is heat that transfers without particles. Like the sun, if you get up in the morning and the sun is bright and it's hot, the sun cannot transfer heat by conduction and convection because there is space. There's nothing between us and the sun, and it is by radiation. All right. Now, again, radiation. I'm not going to go for light and sound. I am just going to go for light. I don't know what sound is doing in there. So this is where radiation is really important, and definitely not music from speakers. We're not going for that. All right. Energy is never lost. You cannot create it. You cannot destroy it. Okay. So you've got 3 worksheets to do. I'm adding something to this. Okay. One of my biggest problems with students who are way older than you guys, who are 18. I was talking to my year 13s last night. They're 18. Is reading. Now, you're all going to say to me, hopefully, I can read. Yes, you can. But there's a big difference between reading, and reciting. And most people recite. So what you're going to do, you're going to do two things. You're going to answer these questions. You are, Mercy, can you get off the screen, please, darling? You should be on Google Meet, sweetheart. So you are either, so the 2 things you're going to do. First thing is, let me get this really big. Before you answer any of the questions, underline the keywords. Right? This is not as easy as it looks, and I don't care if you underline the wrong keywords today. I want you to make this a habit. Slow down your reading, underline your keywords, and I want you to answer these 3 worksheets. They progressively get harder. And there's no way you can remember all this. So you always refer back to the information I've given you. All right, sweethearts, I am going to stop. Oh, no, not the fire juice. It's not year 8. Year 8 are used to you giving me fireworks. This is your fire juice.